Hi there, thanks for tuning in. This is going to be a pretty long video on the concepts of RAID. This feature is very critical and very fundamental for data center setups for servers, NAS, and SAN. I wanted to make this concept video because we tend to forget the basics every now and then, and that includes me as well. So I thought it would be a good idea to put in a video on YouTube and refer it anytime I have any confusion. I hope this works for you as well. Okay, so let's get started. So, if you are setting up a RAID, it would be aimed at achieving three important benefits for the organization: performance, fault tolerance, and disk space. So, RAID stands for redundant array of independent disks. In some cases, it is also known as redundant array of inexpensive disks. The prime motive is, as I mentioned over here, performance, fault tolerance, and space. It spreads data on multiple sets of disks. It creates copies of data and requires multiple disks. You start with two or more disks. So I already mentioned in the previous slide, it is intended for fault tolerance, it is intended for performance, and it is intended for more space or optimal use of hard disk space. So what does it achieve for the business? It protects the data integrity by mitigating disk level corruption. It achieves high availability. This is not the only function which achieves HA, but this contributes to that need. It meets SLO, service level objective, for optimal performance. Now what it means is, like, if you have a critical system which requires very high performance, you would invest in the right type of RAID, and you would also invest in the right technology, which would then benefit in achieving the final business objective. Before I get into the intricacies of RAID setup, let's look at what it is not intended for. RAID cannot compensate for catastrophic failures that could affect the site itself. RAID is within the data center. It is working on the server, it is working on the NAS or the SAN. It doesn't mitigate the problem of a failure which occurs at the data center level. It cannot mitigate soft errors. So if there's an application bug or there's a user error, RAID is unaware of this. RAID will not be able to protect the data in such scenarios. No way it replaces the backup plan. Whatever kind of technology you're using in terms of RAID or in terms of DR or in terms of high availability clusters, etc., your backup plan is very important. Nothing can replace it. All right, so here are the different types of RAID. It starts right from RAID 0 till what we currently have in the market, RAID 60. Now the ones which I have marked in bold are very commonly used. I will cover all of these RAIDs in the subsequent slides. RAID 0. It evenly stripes data across multiple disks to improve performance. It operates at block level. It allows creation of large volumes. So you can club multiple sets of disks to create one single large volume. It is best for performance, as I mentioned earlier. It cannot tolerate failure. So that means this is a no-no for production. We should not look at using RAID 0 on production systems. You may use it on some user-based self-learning systems which can be replicated from production, can be mirrored from production, and can have a downtime which doesn't affect business. It requires minimum 2 disks. So if you look at the picture in RAID 0, when the data is written to the hard disk, it will alternate between the available disks. So block A would go to disk 1, block A2 would go to disk 2, A3 would go to disk 1 back, A4 to disk 2. So it's sort of a round robin. It alternates between the two disks for writing. This gives it optimal performance because the load is now shared between multiple disks. So it's very good for performance, and it is very good to achieve large volumes. RAID 1 is aimed at mirroring data. It mirrors data between two disks. It operates at block level again. It can tolerate up to one member drive failure because data is now being copied onto multiple disks. If you look at this picture, when data flows in for writing to disks, RAID 1 will copy the same set of data on both the disks. So if you see, there is a mirroring happening over here. Same set of data is written on multiple disks. It's good for performance and redundancy. Minimum 2 disks are required over here, and the drawback is you do not get the space benefit which is achievable in RAID 0. In RAID 0 you would just multiply the number of disks with the size to get the total volume. In RAID 1 you have to slice that number to get only 50% benefit. So RAID 1 gives you good performance, and it is fault tolerant. RAID 2 is not very popular, but I'll cover it over here just for the fundamentals. RAID 2 stripes data in one set of disks and uses another set of disks for error correction code. Error correction code is a program which is running behind the scene to generate ECC code, which is then kept in the other set of disks. So you have got data disks and you have got ECC disks. It operates at bit level. I believe this is the only RAID which has been brought down to this level. It is expensive to implement and not useful at this point. The reason being, ECC is a feature which is now available in the firmware of most hardware components. Usually if you set up a RAID 2, you would have a 10+4 disk set or above. RAID 3 brought in the parity concept. So what it does is it has data striped across multiple disks, and it uses a dedicated disk for maintaining the parity. It operates at byte level, and it is not a very good read performer because of the way the spindles move. They are synchronized, and that's the reason random reads are not very good. Minimum of 3 disks are required, and max is controller dependent. What is parity? It's sort of a hash, a key which is generated using the blocks or the bytes from the different disks at the same level. So it's kind of a horizontal. In this case, for RAID 3, data retained in A1, A2, A3 would be used to generate the parity AP over here, AP 1 to 3. Same is the case with the second row. It would generate the parity AP 4 to 6, and so on. Parity is used to recover the data in case any one of the disks fails. If this fails, then data will be used from the available disk and the parity bit to regenerate the lost data. RAID 4 has similar concept as RAID 3. It stripes data across multiple disks, and it has a dedicated parity disk. So you would have your data disks over here and a dedicated parity disk. Now what is different between these two RAID is that RAID 4 is at block level. So blocks from multiple disks are horizontally picked up to generate the parity bit, and so on. It has a good performance of random reads. So that's another difference between RAID 3 and RAID 4. RAID 4 performs very well for random reads. Minimum of 3 disks are required. Max is controller dependent. RAID 5, very popular. It's widely in use. Again, the concepts have built on top of the previous RAID. So it uses striping of data to spread the data across multiple disks. and it also distributes the parity to build redundancy. What it means is that now you're not talking about a dedicated disk for storing the parity bits. You are slicing and dicing the parity bits across multiple disks. So if you look at the picture, the horizontal blocks A1, A2, A3 are picked up to generate the parity bit on the fourth disk. The second row, horizontal block B1, B2, and B3 are picked up to generate the parity bit on the third disk. Similarly, for the third row, if you see C1, C2, and C3 are picked up to generate the parity bit on the second disk, so on and so forth. It is optimal for performance, redundancy, and disk space. So, in this case, you have achieved all the three important benefits of having a RAID structure. There used to be a debate about a decade back on RAID 5 versus RAID 10 or RAID 0 plus 1, and administrators would prefer deploying RAID 0 plus 1 or 1 plus 0 or RAID 10 over RAID 5. RAID 5 used to be considered as a bane and was a no-no for servers. That era is over. Today RAID 5 performs pretty well. It has improved a lot thanks to the technology improvements, and with the nested RAID coming in, RAID 5 is a very good option for larger systems with good performance. Minimum 3 disks are required. Max is controller dependent. Now RAID 6 is very similar to RAID 5. The key difference over here is double parity. That means it has generated two sets of parity for the data. So it does the same thing. It stripes data and parity across multiple disks. It operates at block level. It does horizontal as well as diagonal parity. Now what it means is that if you look at the picture, block A1, A2, A3 would be used to generate the parity AP. This is horizontal block pickup. At the same time, the RAID would travel diagonally across the disks and create the second parity bit. So in this case, A1, B2, CQ, and D2 would be used to generate the AQ parity. So basically you've got horizontal parity and you have got diagonal parity being generated across. This gives an additional level of fault tolerance benefit to the structure, the RAID structure. It can tolerate up to 2 disk failures. It needs minimum 4 disks. Max is controller dependent. RAID DP is similar to RAID 6, but it uses dedicated disks for double parity. So it stripes data across multiple disks and it uses dedicated disks for double parity. Again, it operates at block level. Most of the RAID, popular RAIDs are at block level. This RAID DP has been popularized by NetApp. It is very widely in use on NetApp filers. This is recommended by NetApp to be used on their machines. Again, for the double parity, horizontal as well as diagonal parity generated. So if you see in this picture, A1, B1, C1 would be used to generate the P1 bit, and then the approach would be to go diagonally down and generate the Q1 parity. So on and so forth. It keeps on creating that mesh across the different disks to achieve a very rock solid fault tolerance. This system also can tolerate up to 2 disk failures. Now let's come to nested RAID. So what is nested RAID? It clubs multiple RAID setup. So we talked about RAID 0, RAID 1, RAID 2, RAID 3, RAID 4, RAID 5. So the way nested RAID works is that it clubs the popular RAID 0, RAID 1 and RAID 5 to give you a more high performance, good capacity and better fault tolerance benefit. For this particular slide, if you see, this is RAID 0 plus 1. So the way this works is it follows the IO approach. IO, you can remember this mnemonic. 0 is the in RAID, 1 is the out RAID. So that's the reason I called it IO. So whatever numbers are given in the nested RAID, the first number would be the inner RAID and the second number would be the outer RAID. So if you look at the picture, there are two sets of disks over here. This is combined in RAID 0 because RAID 0 is the inner RAID. Then the next set of disks are also configured on RAID 0. Then at the controller level, you have configured RAID 1. So what would happen now is the controller will send the same set of data to both the RAID 0 structures. And what RAID 0 would internally do, it will stripe the data. It will stripe the data alternating between the available disks. So you're getting the best of mirroring as well as striping in RAID 0 plus 1. Minimum 4 disks are required. Max is controller dependent. RAID 10 is the best of RAID 1 with RAID 0. RAID 1 would be the inner RAID. RAID 0 would be the outer RAID. So blocks mirrored in a striped set of disks. So in this picture, if you look at the picture now, there are two sets of disks. RAID 1 is configured on these sets of disks. So that basically means that the data would be mirrored between the two disks. So that is handled at the subset level. At the controller level, you have got RAID 0 configured. That means the controller would stripe the data between the two sets. So it would alternate sending blocks to RAID 1 subsets. It would send the block A over here, A1 over here. It would send block A2 over here. So when A1 comes down, it gets replicated into two disks. When A2 comes down over here, it gets replicated into two disks. Then A3 would follow again. A4 would come down here, and so on and so forth. You need multiple sets of two disks. Minimum 4 disks are required so that you can have two sets of two disks each. Max is controller dependent. This is best for performance. This is the standard which has been achieved. RAID 10 is highly recommended for high performing volumes. This is again debatable because a lot of technology advances have happened, and even RAID 5 now performs at a very optimal level. We will discuss that further. RAID 50 gives you the best of RAID 5 and RAID 0. 5 is the internal RAID, the inner one. 0 is the outer one. So if you look at the picture, RAID 5 is configured on these three disks. This is the first set. The second set, another RAID 5 is configured, and you might have more sets over here. You can keep configuring RAID 5, and then all these are clubbed under RAID 0 at controller level. When I say controller, it is basically the higher level. The complete RAID structure is defined at controller level. So blocks are striped on multiple arrays of RAID 5. So when data flows into this volume, RAID 0 would stripe the data. So it would alternate sending data to each of this subset RAID structure. So it would send over here A1, A2, it would alternate and send A3, A4 over here, and A5, A6 to another set, and so on and so forth. So you're getting the best of fault tolerance, space, and performance in RAID 50. You need multiple sets of 3 disks each. Minimum 6 are required, max is controller dependent. RAID 60 gives you the best of RAID 6, which is double parity, and RAID 0 striping. So 6 is the inner RAID structure, 0 would be the outer RAID structure. So if you look at the picture, RAID 6 is configured on the independent sets of disks, and then these are clubbed into RAID 0. So blocks are striped on multiple arrays of RAID 6. So in this case, data would be alternated between the two sets. A1, A2 would be sent over here, A3, A4 would come over here. So you're sending different sets of data, alternating between the sets, and within the RAID structure, your horizontal and diagonal parity would be generated to create a stronger fault tolerance. Multiple sets of 4 disks are required, minimum 8 disks, max is controller dependent. So that completes the fundamentals of different types of RAID. I have again highlighted what we covered, right from RAID 0 to RAID 60. The ones marked in bold are the ones which are very popular, which are widely in use today as of this time. I have personally used RAID 10 and RAID 50 in most setup, and they have done very well for organization. Now RAID setup applies to servers, SAN, NAS, and even independent workstations. If you have critical workstations, you can set up RAID. Now how is RAID implemented? You have two types of RAID again over here. The approach, basically there are two approaches. You can have a hardware RAID and you can have a software RAID. The recommendation all these years have been to go with hardware RAID because they had better controlling capabilities and well performing. They're better performing compared to software RAID. Hardware RAID normally are configured at controller level, the most common way of configuring. They also come in BIOS nowadays. So if you have a workstation which needs a RAID setup, you can do it at the BIOS level depending on what kind of machine you're procuring. Software RAID is at kernel level. You can have it at the operating system kernel level. You can configure it over there, or you can go with the file system based RAID, which is very popular nowadays. You can look at file systems such as ZFS, which are very popular and extremely well performing and fault tolerant. Alright folks, few things I wanted to discuss one to one regarding the setup consideration, what you should consider when setting up a RAID architecture on your systems. Now, wrong choice of RAID type could deteriorate your system performance. It is very important that you choose the right RAID type to ensure that your business objectives are met. So if you're looking for optimal performance, if you're looking for space, or if you're looking for the fault tolerance capability, be very careful, be very clear about what has to be achieved. To be safe, look for nested setup, look for RAID 50, look for RAID 60, look for RAID 10. They are very rock solid RAID architectures. They will work out for all the benefits of RAID environment. Another recommendation, create multiple pools of RAID. Do not depend on one single pool unless it's a recommendation from the hardware provider. For example, NetApp filer. If you buy a NetApp filer, they would normally recommend that put all the RAID, all the disk under one controller on one RAID DP. Some of the NetApp filers have this recommendation. But again, if you have the flexibility and there are no hard and fast recommendation on the hardware which you have procured, please go ahead and configure multiple pools. That gives you the advantage of load sharing or slicing your workload. Another important consideration, spare disks. Never forget to put spare disk on your box. Spare disk would be used when a disk in the RAID setup fails. So, for example, if you have a RAID setup of, let's say, 5 disks, one of the disks failed. The system would look out for a spare disk if you have configured one and replace the failed disk with the spare one. When a disk fails in a RAID setup, the system goes into degraded state. Not the system, rather the particular RAID goes into degraded state. Now you have to bring that back to healthy state. To do that, the system will automatically look for the spare disk and try to replace the faulty one with the available spare disk. That saves a lot of time and effort because your manual intervention is not required. The system will be smart enough to look out and replace the faulty one. So your RAID structure is back to normal state, healthy state, and you have time to replace the faulty disk at a later stage. One more important point, always have the same type, size and speed disks under one RAID structure. Do not create a mix and match of multiple configuration disks. You will land up in unwanted, unnecessary performance degradation, which will be too late for you to handle at a later stage. So as a rule of thumb, always have the same type, same size, same speed disks under one RAID structure. The next 2 points are the technology changes which have improvised the RAID concept. That is the reason I said RAID 50 or RAID 5 improved performance because of these technology changes. One is cache. Cache is very critical for the performance of your RAID setup. So when you buy a SAN or a NAS or a storage box, you have a cache element which is available at the controller level. The cache is used for all data coming in and going out of the box. The cache is a layer which determines performance for the setup, performance for the box. The RAID controller is smart enough to utilize the cache for optimizing the performance of the box. So for if there are frequently used blocks on your RAID, so-called hot blocks, the controller would pick up these blocks and cache them. It will be available in the controller cache so that when a request comes from the source system to provide data, you don't need to go down. The controller will not go down to the disk level to pick it up again and pass it back. That is creating a little bit of additional overhead. Rather, the most frequently used blocks will be available in the cache and the controller will immediately transmit it back. So if you're in the market to buy a new hardware, a new storage, do not be a miser on the cache side. The highest available cache, go ahead and get it. That is one of the main performance contributing factor which you do not want to mess with. Next is solid state disk or flash disks. The new boxes which are coming in the market, the new storages, they are extremely high performing because of this reason. SSDs are high performing components which are designed on the concept of chips, and they do not have the moving parts which come with the traditional hard disks. Now flash disks are pretty fast. There is no doubt about it that you need to If you have a requirement for high performance system, flash disk or solid state disk is the way to go. If you have an existing storage where you want to improve performance, you can look at adding a pool of, you can look at adding a volume of solid state disk under the same pool. What would happen is there's a concept of easy tiering where the controllers would pick up the hot blocks or the highly frequently used blocks and pass it and move it to the solid state disk. So it's kind of a tandem which happens inside the RAID setup. But the benefit is that with this setup, you would achieve about up to 300% increase in performance with your traditional setup. So you're combining the SAS setup along with the solid state disk setup to achieve this performance. If you are in the market for a new box, do your due diligence to get a box which is geared with complete SSD set. You will just kill off any performance headache you would have in the future upfront. And finally, the last point, this defeats all technology we just spoke about. It's the programming part. So if your software is not geared to make use of the technology we put in, the performance benefit will be lost. Quite often you might have the state of the art systems, the best of the hardware with you, but because the software, the way it was written, the way it was designed, is not capable of handling or making use of these benefits, you might have a degradation in the performance of the application, which then means that you need to fix the application layer itself. So this is another vital factor. A lot of older software are not geared for modern generation platform. If you have a homegrown or inbuilt, internally built custom software, they suffer a lot because they are not in line with what is happening in the industry. You need to look back, you need to check out these software and see if you can improvise on these to make use of the modern stuff, the modern technology which is coming in. That will add in to the total benefit you get from such setup. Well, that is all, folks. Thanks for being patient to go through the complete video if you have done it. I know it's very painful, but it's a concept which has been there for generations now, and it's worth going through these concepts once in a while to understand and connect with the source. Thank you.